Hello everyone, we'll be continuing the previous class here. Okay, so we are done with this in the previous class. Okay, now we'll be going for the UDL loading. Okay, in this case same thing we'll be starting with, no difference in this. Okay, we'll be taking along this beam L, okay, as a length L. There are 2 points fixed in the free end A and B. So at a section we have to take a section XX anywhere on the beam at a distance x as it is taken here. Now you have to calculate the shear force for the section XX. Okay, for that, so what will be the shear force? What is shear force? Once more, you go to the definition and then you come and will start. Definition is algebraic summation, right? So it is algebraic summation. So the force, that is W, because it is downward force, so it will be positive, right? It will be positive, into what? How much is the distance? Because this is UDL, right? It is per unit length. The load which is given is here per unit length. It is not a point load here. So we have to multiply it with the length. What is this? What is the distance we have taken? At what distance we are calculating this? It is we are calculating for x distance, right? So it will be plus W into x, that is shear force at x. Okay, this will be our formula for shear force about the section XX. Okay, so now we'll be substituting this x, okay, at 2 points, that is point B and point A. If you want to calculate the shear force at point B, okay, what will happen? It is at that zero distance, right? BW into 0, it will be 0 here. Why 0? It is at the free end, right? From, if we take that B as a reference point, okay, and we are calculating shear force at that instant only, so the the load is there at that B point. There might be some load, but the distance you have to multiply, right? Distance will be 0 because we are calculating the shear force at the point B, and it is the starting point of your beam. So you don't have the distance only. Distance is 0, so value will be 0. Next is shear force at A. So we want to calculate the shear force at A right now. So using this above formula, W into X, okay, the positive sign, W into, what is the distance from the load to the A point? It is L, right? It is along the whole length of the beam. If it was the length was, if the load was to the certain length, then it would be taken that much length. It is along the length of the beam, that is L. So we will be taking length L. So it will be plus W into L. This is your final answer, kilonewton. Okay, or Newton it is. W into L. This is what the shear force is. Okay. Now we will be calculating bending moment. Okay. We will be calculating bending moment. For bending moment, what it is? It is the load into vertical or perpendicular distance, right? So for this, what we'll be doing the same thing. We'll taking the cross section XX at a distance of x. So the bending moment, okay, it is W, but what is the sign? It is downwards because the load is acting downwards. The beam will be tilting downward, so it is minus will be using, it is bm or mx. Okay, it is minus w, that is the load, okay, into x, because to the x distance, where it is, from where we have to take, this is what the load is now. The whole is considered as load, because the load which is given at UDL is for the per meter length. So you have to consider, if you want to calculate the load into distance is necessary. It is the unit length, unit force. So you have to multiply it with the distance. So again, how much distance you are taking? If you want to consider it, you have to consider this as now. Once you multiply W into X, this will become a point load. This becomes a point load at the mid of this X, here like this. If you see, okay, if you see here, I can expand this, okay. If you see, once you multiply W into L, okay, that will become a point load, which will be acting at the center of the distance X. So from this point load WL to the section X, how much is the distance? It is X by 2, right? It is X by 2. Okay, so what we'll be doing is, we will be multiplying it with X by 2, because that is the distance you are going to multiply. This has become the load, this will become your distance. Understanding what I am saying? Okay, this is how it works in the UDL in case of bending moment. So what will become, mx is equal to W into L, that is your point load. What is the distance? It is half the distance what you have taken. It is not L, it is X, because we are calculating for the X distance, right? It is X, okay, into X by 2. So what is the formula? Wx square by 2. This is your final minus. Don't forget the minus sign. This is your formula. Wx square by 2. So we have to calculate the bending moment at which points? Only at one point, because this is a free end. Bending moment will be at B will be 0. Okay. And now we have to calculate bending moment at A. Use the same formula. W, what is the total distance? It is L square by 2. This is your final bending moment at the section A. At the section A, this will be your bending moment acting on the beam. Okay. So we'll write the we'll draw the shear force diagram. Okay, I said that in the UDL it is inclined line. In case of shear force, what is the bending moment shear force at the B? It is 0, and here it is how much? At the A it is WL. So raise it to WL and just join it like this, because it is positive, so above the baseline, that much is the value. Okay, this is a shear force diagram. Now same thing is a bending moment diagram. In this case it is minus, so below. What is the value at B? It is again 0 here, and at A it is WL square by 2. So you come WL square by 2. It is not fixed that you have to take this much distance. but just come below and just join it. You can't join it by straight line, you have to join it by parabola, because it is UDL in the bending moment. You have to draw it with the parabola. It will be like this. Okay, this is how is your bending moment, right? This is how your bending moment is.